Dear students, this is about matter around us. In your previous classes, you learned about metals and non-metals, artificial fibers, I mean to say synthetic fibers, and natural fibers, acids, bases, and salts, musical instruments, the food we eat, water we drink, air we breathe, clothes we wear. All these are called matter. By observing all the things, we can say matter must have mass, should occupy some space. If these two things are satisfied, then we can say that is a matter. Matters contain very tiny particles. The arrangement of these tiny particles decides whether the matter is solid or liquid or gas. These are the three states of matter that you are going to learn. And one more is there, which is called the plasma. Now, how the molecular arrangement and what are the characteristics of solid, liquid, and gas? Let us see. In solids, the tiny particles are tightly packed and they are not able to move, but they can vibrate. The kinetic energy of these particles is too less, and solids have definite shape, solids have mass, and solids have definite volume. Consider liquid. Tiny particles arranged in such a manner that they can move and they have somewhat less intermolecular attractions compared to solids. So they have higher kinetic energy compared to solids. And liquids have mass and they have definite volume, but they don't have definite shape. They have shape of the container gas. Here the tiny particles are too far, so the attraction force is very less. So they don't have definite shape, they don't have definite volume, they have mass. The kinetic energy too large compared to liquids and solids. As the separation between the particles is more, they have enough space to move. And the fourth state is plasma. This plasma state can be obtained in two ways. One is by giving sufficient voltage to the gas, and the other way is to give extremely high temperature to gas. When the high temperature is given to gas, then the electrons will move away from the atom and they have very free space to move, and there exist positive ions. The combination of these free electrons and positive nuclei is plasma. Plasma can be observed in some types of flames on the atmosphere of sun and stars.
Matter can be changed from one state to other if sufficient or specific physical conditions are applied. Means a solid can be converted to liquid or liquid can be converted to solid and so on. Sometimes solid can directly convert to gas without involving the state of liquid. These processes have specific names. When a solid is converted to liquid, that process is called melting. And when a solid is directly converts to gas without involving the state of liquid, then it is called sublimation. This is possible in the case of camphor, naphthalene balls, and in the case of iodine. When a liquid changes its state to solid, then it's called freezing. When a liquid changes to gas, this process is called vaporization. When a gas changes to solid without involving the state of liquid, then it is called deposition. When a gas changes to liquid, then the process is called condensation. The temperature at which solid converts to liquid is called melting point, and for the ice, the melting point is 0 degrees Celsius. The temperature at which liquid boils or vaporizes is called boiling point, and the boiling point of water is 100 degrees Celsius. Here some ice cubes are taken in a beaker. If you observe carefully, the particles are very close to each other, means they are closely packed. If you supply sufficient amount of heat, I mean to say, if you increase the temperature, the molecules acquires sufficient energy and they are able to move a little bit. Then the molecules acquire, or the tiny particles acquire sufficient amount of energy by the supply of heat by increasing the temperature. Then the ice melts to water. When this water is further heated, then the molecules or the tiny particles move far apart and their kinetic energy is increased a lot and the liquid becomes vapor. This is iodine. It is heated to sufficient temperature. So we observe some beautiful purple fumes. This is an example for sublimation. Here the iodine directly converts to the gaseous state, and if you cool the fumes with the help of ice cubes as shown, then after few minutes the fumes will solidify. Here there is no state of liquid. Solid is converting into fume and fumes are converted to solid. The conversion of fumes to solid is called deposition. So using iodine we can explain the sublimation and deposition. There are two terms, vaporization, which is also called boiling, and the other is evaporation. Both are a little bit confusing, but the difference between these two is, for example, if you consider water, the boiling is possible above 100 degrees Celsius, means it should be possible above the boiling point of water. But evaporation can be possible if boiling point is not reached. For example, if you keep your clothes, wetty clothes outside, the day temperature is around 40 to 45 degrees Celsius. Even though the wetty cloths dry in some time, this is because of evaporation. In vaporization, you observe the bubbling effect, means when the
liquid is heated properly, then after reaching boiling point, the vapors come out. You observe bubbles in the liquid, but the bubbling effect is not there in evaporation. The process of evaporation is slow and the process of boiling is quicker. The process of evaporation depends on few factors. One is temperature. If the temperature is more, the evaporation will be more. And second one is surface area. If surface area is more, evaporation is more. Keep hot coffee in cup and hot coffee in a bowl like this. Then this coffee, I mean the coffee kept in this bowl becomes cool quickly compared to this one, because the evaporation is more here and the evaporation is less here, because the surface area is more and the surface area is less. And wind speed also affects the evaporation. If wind speed is more, then the evaporation will be more. The rate of evaporation increases with speed of wind. And humidity is also plays an important role. Increase in humidity slows down the evaporation. Compressibility of substances gives the information how much volume is changed on the application of pressure. Compressibility of gases is too large compared to the compressibility of liquids and solids. Gases are more compressible because the space between the particles is too far compared to liquids and solids. Three empty syringes are taken to explain the compressibility, and these three syringes have frictionless piston and rubber cocks are inserted as shown, and in one of them is filled with chalk powder and other with water, and the other one there is air, and the levels are same, and you have to apply equal amount of pressure on the three syringes. If you apply more and more pressure on the first one, which is having chalk powder, then the compressibility is not there. If you apply pressure on the syringe which contains water, there is a little compressibility. If you apply pressure on the third syringe which is empty, means which contain air, then the compressibility is more and the piston moves a lot distance in the syringe. This shows gases are more compressible compared to solids and liquids. Diffusion, this is the process of intermixing of particles of different substances. When two substances, maybe solid liquid or liquid liquid, liquid gas or gas, when these are mixed, then the process of mixing is diffusion. If the diffusion takes place between two substances, then the particles move from a region of higher concentration to a region of lower concentration until a uniform mixture is formed. This diffusion is useful in our daily life. Due to diffusion only, the oxygen from lungs moves to blood, and carbon dioxide diffuses from blood to lungs. The diffusion of oxygen into the water supports the life of aquatic animals, and in plant growth, water present in the soil diffuses into plants through the root hair cells of the plant. Water is taken in glass tumbler. Yellow color solid is allowed to drop in the water. Then the particles of solid are diffused to liquid as shown. Here water is taken in the tumbler and a purple color liquid is allowed to drop in water, so that the liquid and liquid diffused as shown. This gives the information of dependence of rate of diffusion on temperature. The left side tumbler is with hot water and the right side with cold water. You can see that the diffusion is more in left side tumbler, means if the temperature is increased, then the rate of diffusion will be increased. This is the experiment to show the rate of diffusion of gases. Two cotton pieces are taken in which one is immersed in ammonia and other in HCl. When these two react, you will get ammonium chloride in solid form. To do the experiment, we need a glass tube in which pH papers are inserted as shown, and these two cotton pieces are kept like that. The pH papers are included because ammonia is alkali in nature, so it turns the pH to blue color, and HCl is acidic, so it turns the pH to pink. After the reaction is done, we observe a white colored ring there, which is ammonium chloride, which is formed because of the reaction between ammonia and HCl. This white colored ring is near to HCl. It means that HCl travel least distance compared to ammonia. Means the rate of diffusion of ammonia is faster as it is lighter to the rate of diffusion of HCl as it is heavier. Take 2-3 crystals of potassium permanganate and dissolve them in a beaker of water of 100 ml, and take out 10 ml and add to 90 ml of water again. Then the same color, which is purple pink, is observed, and continue the process for 5 to 6 glasses. The intensity of color is decreased, but the color remains. Means we can say within that 3 crystals a number of particles are there. So we can say matter is made up of very large number of particles.